So what we are going to do today is ANN, Artificial Neural Network, deep learning. You can say that also. So let's understand that. We have to understand how the nerves are, nervous system, not nerves actually, our nervous system works, and according to that, deep learning is designed. AI basically is designed based on that, but we are talking about ANN, that is Artificial Neural Network. That means you have to artificially design a human brain type of a thing, right? Okay. So what we have here is like a human brain has 100 billion neurons, and these 100 billion each neuron is connected with around 1 lakh neurons. Okay, so they are interconnected. One is connected with the other, and the others are connected with the others, and so on. So one neuron is again connected with around 1 lakh other neurons. Okay, and that is what robotics and deep learning or AI is aiming at, designing something like a brain, how brain thinks and how brain works, so that we can get the output, desired output rather. So in our nervous system, you have neurons, axons, dendrites, and other components. So neurons actually, the signal is passed on to axon and to the dendrites, and the signal passes through something called synapse. Okay, so you can see this something like this. Synapse. I have not labeled it. I've just copied from somewhere. I think I had put the source, but it is not here. Anyway, we have more. Okay, so weights are to connected at each synapse. Weights are important in neural networks. Actually, they help in deciding how far the message goes, a signal can go, and then how it is connected to the others. One neuron, one message may not be able to travel through one neuron, so they are interconnected. So the signal passes from one to the other, and so on. It keeps on passing till it reaches your brain, and the processing is done, and it is again reverted back. Okay, so we have, you can decide the weights, modify the weights to train your network. Okay, so in ANN, okay, not human being. We are not talking about human nervous system. We are just trying to create something like human nervous system. Okay, so one neuron alone won't be useful unless it is connected, as it has its own range and weight. According to the weight, it can travel to a certain distance. So if I say information won't be able to pass to a long or make any sense unless the other neurons are connected. That means one neuron is taking one message or one signal, and the other, if they don't combine together, then it may not make any sense. It is like parallel processing we are doing. So your packet is divided, and if it cannot actually get together, then it won't make any sense, right? So neurons and all, they are interconnected, and they keep on passing, and we have to design something like that. So in our case, it is like layers we design. Okay, so deep learning algorithms work with layers. Like we design a single layer, and that produces an output which becomes the input for the next layer, and it keeps on we keep on doing that until we get the desired output. Okay, so you can see that neuron receives a signal or signals that pass through it, and the output signal is sent by that neuron to the other one. Okay, that is the output of one neuron or one layer would be the input for the next layer or neuron. You can say that. Okay, For one singular observation, you can take an example that independent variables are there. Then, if I'm looking at something, then if it is a binary data or an integer data that is broken in to parts, and then it is passed on to one layer. It The features, we call them features. So the features are extracted and passed on to one layer, and what it learns from it, what it interprets from the data, is the input for the next layer, and it keeps on passing until it makes sense. The data makes sense, right? So you can correlate with your human brain, but in computation, in computers, or in AI, when we are programming, they are actually layers. So we have to design some layers and see. We will be looking at some boosting algorithms also. We have cat boost, light GPM boosting algorithms. They are machine learning algorithms, algorithms, something like that. And ANN algorithms also, recursive neural network, RNN. LSTM is the most common of them. So we'll be looking at that also, right? So one by one, we're seeing that. But let's see what we have in the ANN. So there are two methods, major methods, for programming what you want or what we want, and they are like the pre-programmed. The first is a method that is pre-programmed. Okay, so you tell the software exactly what you want it uh, to perform. Okay, so it's a pre-programmed method, like that this is the input and that should be the output. Okay, so you tell the input also, the output also. Uh, so yeah. Then we have the matter of neural networks. In neural networks, you tell the network that what inputs to use and what outputs you want. That is what we talk about, the pre-train, and we have to learn from it. We can avoid having to manually enter all the rules by enabling the network to learn on its own. It is like we give that input and the output, and whatever input, raw input we are giving, that could be used by one layer, and the output, what it learns from it, is passed on to the other layer, and it keeps on till it reaches the output which is desired. Okay, so you can design the architecture in such a way that it works, and once it's been taught, the feed you can feed it fresh data, and then you can predict the output. Okay, so first thing is to train your network. Okay, train and testing data, that is what we always do. Training and testing, we split the data into training set and testing set, and then we get the whatever output we get from that can be used, or the model which is trained now can be used for the input. That is a raw input we can take later, and then we can see that what happens, right? And the predictions can be there. So we can see that we have already seen that the accuracy and all we get, but predicted values also we have seen that this is what we gave the input, and the output was what it was. Okay, dyslexia, dysgraphia, we saw that also. In that case, also we had. Okay, now we have two major types, like feed forward network and a feedback network. There is other also. We'll come to that. Feed forward is you learn and pass on, learn and pass on, learn and pass on. It won't go back. What you have done is done. It won't come back and tell you, okay, okay, this is not working fine. You learn again and you pass on again. So it won't do that. It will just learn and pass on, learn and pass on. Okay. But in a feedback network, it is like you learn, pass, then come back and see, okay, this is what I can learn better or learn more, and then pass on. And it is like to and fro motion. learn from the data, the output is forwarded to the next layer, and then it comes back and sees what it can learn again, or what mistakes it has done, and you can just go forward. It is like a human brain, like we keep doing things every day, but if we go wrong somewhere, then we just go back and think and see what was wrong and what can be done, and where we went wrong, what we did wrong, and all. Okay, so we can do it that way also. So human being brains can do, and so does uh, network can also do the same. Okay, so we have to actually train our networks in such a way that we can learn from mistakes. Okay, so you have to learn from mistakes and learn from actually example also. So learn from example, learn from mistake, feed forward and feedback network we have. So let's see some implementation. We have two options here. We have PyTorch and we have tensors. So let's see that, and how we implement it, how we can do it, a little bit of that. So let's have it from PyTorch. PyTorch. Okay, now we have PyTorch, and how we call PyTorch. People use it a lot. Personally don't like it much, but anyway, I just paste. Okay, and let me see mlist dataset we'll take. Mlist is a dataset of the feedback of the movie reviews basically, and there are a lot of datas there, so you can just I'll have to run it and check first that Torch is installed or not, but I think it is there in Collab. Torch and tensors are already there, so you don't have to worry about it. It should be done without any issues. Let's wait and see. I'm sure it will work. Come. First time it takes time. That is what Collab is all about. So we are loading. Okay, now so it is working. Now that was actually we're calling the modules. Then epochs, batch size, that I'll come to. Epochs is a repetition actually. It is iterations, how many times it has to repeat. And batch size is how much data has to be passed one by one. I'll give you the theory of that. And this is just creating a data set, MNIST data set, and you're reading that data set. This is how we can use PyTorch to understand the data. Let me tell you, put some theory about epochs and the batch size. Okay, this is the sample size. The batch size, the number of samples you process at one go, and epochs is repetitions, basically number of iterations you can say, and it helps. Uh, but you have to be little careful. Sometimes it can be it can cause an issue if more epochs are there or less epochs are there. So you just have to be in between so that you get better results. You can play around with that and see. Now, okay, so we have already taken the data that is from the data loader. We will be taking the data torch.utils.data.data loader x y train pt that we did earlier. Batch size is batch size, which is already given. Yeah, x y train, that is torchvision.dataset.mns from the root training true, download true, transform torchvision.transform.compose, torchvision.transform.train. So this is the syntax we use to read the inbuilt dataset. This is already a preloaded dataset. Now, uh, what we do is data dictionary using to extrain batch size. We have already got that, and just have to just visualizing the data, and then in from for IDX index in p.a range, we are doing that. Then image and label. This is an image data set. I'm just missing. That is, we have images also, and we have the movie reviews also, and we have some cancer data sets also available which we can download. Okay, so image label extend index. From there, and we are taking an image and see. I'll just show you the output, what it shows. This is what it is showing. This is the data you can say. So this is just a plot of the data which was given to it. Okay, so not the model till now, just the data set. Okay, now we can take the data and see. Just visualizing. Okay, this is just how we use PyTorch. Nothing as such a training and testing types. So from image extend PS0, we are taking one image, then the print image size. That is, we are printing that. Then we flatten the image, and then again we are printing the flatten size. Dot size. We can reshape that and see what happens. So this is 1 by 28 by 28, and this is 784 and 784. There are two, I think, images. Okay, we have this. Okay, dot size 1 by 28 by 28, and this is 1 by 784. That is what we get when we flatten the image. So you can get like this. So anyway, we are just uh, getting the data, saying how we implement tensor and PyTorch. No predictions as such, just an implementation. We'll be doing that. So I have to put it here. I have put it in the wrong place. Tensor. It is a multi-dimensional array only that we have already seen. So let's have some data here also. Just application, nothing else. Implementation. We have a torch random, that is we have generating a random array, printer that, and then torch.tensor. These are the values we have put here. Okay, so whatever the values we have got, we have put it. And these are the two things we have. One is random and one is by torch. Both are arrays, multi-dimensional arrays. You can see that I can get the size and the dimension. You can see that size of this A, and then the dimension of A. You can see that. So dimension is 2, multi-dimensional, and 2 by 3. That is the size of the array we have given. And you can see that it is always with the torch. So we're using torch and tensors together. Now matrix generation. Okay, just a generation of a matrix, a zero matrix 2 by 4. And then we can have a torch dot tensor like this. So we have both the things. We have one is the using the torch this way, or we can have the tensor torch dot tensor and generate another array like this. So that is also possible. Okay, so now let me see. This is just an application. Uh, no predictions as such, no data sets as such. We're not doing anything as such. We're just seeing that how torch works and how tensor works. Okay, what we can do with tensor and what we can do with torch. So with torch we can generate, we can combine torch and tensors and then get the data. Just show you another example of zeros. Torch dot zeros 2 by 3, print p, then torch dot tensor. Again, so almost the same thing we're doing. This is what we got. Torch dot ones. This is a ones. This is zeros. We can generate like this also. And to access that, we can have something like you want to replace, suppose we can replace directly 300, you put 222, so you can see that it is replaced. So you can play around with the tensors, the torches, whatever you want to do with that. You can do. As I told you, these are just tensors and torches, nothing else. There's no rocket science here. There's just a simple matrix implementation of the matrix, nothing else. We're not doing any deep learning here. I'm just showing you what output we get when we do this. Okay, so we can have a torch, that is a list we are converting into tensors using torch.tensor, then print text, you can see this, and then torch.tensor, we have the data 1 2 3 4 1 2 3 4 5 6 7 8, like this also, this way or this way, same thing. Then what is there stored, column 1 tensor, then column row 0, then row 0. This is just access of how you access your data. So you can use torch.tensor to convert the data into your tensors also, and we have access to tensors directly also. We'll be doing that also, but for now I'm just showing you that how the data is used. So np.array, we have a data here. You can see we already did earlier also, but now I can actually transform that into torch. See, when we are using deep learning, either we are using torch or tensor, so we have to get the data in that format. That is why I'm showing you this, that you have to convert this data into the format we want, otherwise it is not going to work. Okay, so let's from numpy, just converting this x into dot tensors. You can see that tensor is there automatically. You can see that it is there. So we have different ways, and we can now see that how we can actually implement a model. So let's have it. We'll combine everything together and see how the thing works. So one by one. Okay, so we have the model ET, that is the name of the model again. Then torch NN neural network dot sequential, that is the neural network model we are calling. Then we have linear. Then we have a sigmoid layer, linear layer, sigmoid layer, linear layer, and log softmax. That is the last layer. I'll show you the model and then you'll be able to understand that later. But just a syntax, just for the sake of introduction, I'm giving you this. But you may not be able to make much sense of it. But now you can see that we have layers here. The model is always sequential, neural network sequential. Then we have linear layer, sigmoid layer, linear layer, and long softmax layer. That is the last layer. Normally, softmax is the last layer. Dimension 1, you can see the given the dimension 784 by 10. Then sigmoid is empty, then 10 by 10, and then the dimension it varies. Okay, it depends on the data set we have. Then this we did earlier, and then we loaded the data also like this. Correct count, all count. We are having the images. So we are reading the images and passing on to the model and trying to predict if it is matching or not. I'll just show you. Accuracy is very less, point percent or something like that. So that is very less. You can see that. you can implement on tensor and get a better result. And this is very complicated, so I normally don't use it. It's not necessary. So image labels, in loading from there, we are reading the labels and the images. Now for in range length the labels, image 1, view 178, log pops, but we are getting the image, then expand, then converting into list, finding the probability of the image matching or not, and the labels, and so on. So it is a little bit complicated to implement a torch. So normally I avoid, and I don't get very good results also. So you can use tensors and do it in a better way. So, okay, let's have this now. So import torch, then neural network, then util data loader, then data sets, then total tensor, lambda compose, then pipeline. Our training data is dataset.fashion mnest. From fashion mnest, we are loading the data. Again, root is data, true, and then transform is a tensor. Now download test data from open datasets. Then this is fashion mnest, again same thing. Training data and test data. But here what we are doing is training is false, download is true, transform is tensor again. That is the only difference between the training data and the testing data. So we are just downloading, it will take time. So I'll just run it. It downloads. Okay, so we have the data now, which is already now downloaded. Very simple, nothing much. We're using torch here, but implementation is little better now. We'll be using torch tensors. Now we know that we need a batch size, so we have to give that. We normally use 64 bit. We can have, this is just a display of the data we have. Batch size is 64, then training data loader that we have already loaded, and test training loader. So we have to load the data as the training and the testing, and then we are just printing and seeing the shape like what we got. So x is 64 by 1 by 28 by 28, and y is 64 bit. So the rows should be same. The first element you can say. Now we want to implement that on your since it is a tensor, it would be using CUDA, that is your parallel processing GPU. So we are using a GPU or CPU. So if you are using a CPU device, then you have to use like this, or I'll have to convert it. 1 minute. Runtime, change runtime type to, and want to change it to GPU. Okay, we have to save it, and then let's run and see if it works on CPU or GPU. It will tell me. If CUDA is available, it will work on GPU. Tensors work on tensors, and torch they work on parallel processing. They need GPU. Okay, torch is not defined because I have to run it again. I'll have to run everything again because I have changed the process the type runtime to GPU. So I'll have to run it again, everything. Now it is on GPU, so it will tell me. From runtime you can change, okay? From here you can change the runtime. Let's see now. It was CPU earlier, but my tensor won't work. It is now CUDA. That is, we are working on GPU. It is not CPU. CPU is a single processor, so all processing won't work. So it will be defining the model, and we have to get the CPU or GPU. So that is we have already done, and this was earlier, so I don't need it actually, this one, but it's okay. Now, we have to define a class neural network, and here we are passing neural network model. Then we have defined the model, function, initialize self, then super neural networks, initialize, self flatten. You have to flatten the data. Then these are the layers again, the same, but here this is a difference. We have a linear layer, ReLU, and I'll come to the different layers we have. So neural network, linear 28 by 28, 512. Then neural network ReLU, then 512 by 512 linear layer, then ReLU layer, then linear layer. And this is for initialization. Then forward, we're using feed forward. So forward self x, x self the flatten again. And then we have one layer that is renew layer, that is stacked layer, and then logic, it returns the output. So now model neural network dot to device and print model. So we're just printing the model. We are not doing anything as such. Neural network and then dot model. We're just passing on to device and see what happens. Okay, so these are the layers. You can see that the features and the data. Then we have to define a cross loss function. Here we'll be using cross entropy loss function. Optimizer is SGD. We need an optimizer also. These things you may not understand now because I've not given you the details. I'm just trying to show you that how it works. So I'll be giving you that also. So need not worry what everything is all about. Then we have to create a function to train. So data loader model loss function. We already have the loss function, and the optimizer we have. We need a loss function and optimizer to actually understand, to make our network understand. Okay, so length of the size, we have found the length of the data loaded and data set, and then model or train. We're training the model. Then load the data x and y, that is x and y. We have to get the data in the training set and testing set, that is always x and y. Then predicting, for predicting we are calling the model. We have the model, then loss function, then back propagation we are using here, and then we are just doing the sizing and all. We'll have to call it. This is a more of a complicated function. We have to define few functions here. Then we need a training model and the testing. This is for testing. Again, won't do anything. It's almost the same. The training set and testing set. We have now the training and the testing, and then now we have to give the epochs, that is iterations, and then we have to see call them one by one. As the model. Okay, epochs, print epochs, train and test. Train mod function we have, and the test function we have. This is the test function, and this is the train function. The data will be passed per epoch, that is per iteration. Average loss, and we can say it keep on. We have only 8 iterations, so I'll be making it simpler for you guys. This is just an overview of how things work. I can see that it is more complicated than it actually is, but you can see that the accuracy is increasing. Just wanted to you to understand what epoch is all about. Epoch is number of iteration. That's why I put it in a loop. Otherwise, you don't have to actually. Okay, so just to show that one by one, we are putting the data and getting the output. So it is training, passing, training, passing, training, passing, and since it is back propagation, so it will be understanding from come back. It can come back and understand and learn again and proceed. Okay, so we have done with it. Now let's see. We have the accuracy, which is not very good, but that's okay. Then what we can do is we can always save this model dash.say model dot state dictionary model dot path, then save. So we have saved it and we can call it later. Just say that model neural network, that is the class we had, and you can see the path. And then I can pass on any data and work on it. Okay, so we are loading that model.load state dictionary neural network. So we have just loaded that what was there, and then I can evaluate it by simply passing the data, a different data to it. I have some data. We'll just see that what output we get. Like this, I can pass, and you can see that. I don't have to call the model again. I just have to pass on the data. Okay, so this data can be saved. You can predict it as ankle boot, actual is ankle boot only. So 100% match of the data. We had trained and tested the data on something else actually. The model was tested on something else. It was on fashion data set. Okay, but what we have now passed on to this model is again related to clothes. So we have sneakers, t-shirts and all. We have passed on that. And model.evaluate simple. If you have new data now, all I have to do is just put the classes which already we have. These are the classes which were there in the data set, in the fashion in this data set. Let me see if I can find that. Okay, if I can find, I can share. It is on Kaggle also. I just want to see. No, this is not the one. In TensorFlow, I think I can get that. Mhm. Yeah, it is there. Description and all. I'll share the link with you. You can. I'll just put the link here so you can have a look at the data. At the end, I can put the last one. Let's put it here. The keras can also be used for deep learning. That is what actually we'll be using. But in the backend, what works, that is what we have shown here. In the backend, it would be tensors or or torch. So you can use when we are using tensor. Basically, these are the multi-dimensional arrays only, but it uses GPU. So for that, I had to change the runtime. This runtime I had to change. You can change the runtime. You can see that it is GPU. So it's fine for now, but it was none earlier. So by default, it was CPU. So I have to change it. When we do parallel processing, we are using GPUs, and the processing is fast, and can do things easily. So just trying to relate your theory with the practical part. So I've just put in few things here. It may look very complicated for now. Much Your machine learning is much simpler. Deep learning is little something like this. Neural network is there. So when we're talking about neural network, we're talking about deep learning. But this is how it works, or we'll have simpler ways of actually implementing the things. I'll just first save it. Okay, I'll share the link with you. Where are we? Here. I'll put it here. I have put it here, and I'll put it in the group also. I have shared it now. You can work on it and try to understand how things work. But again, as I said, this is little more complicated than actually it is. It is not that complicated, but we have to understand that it works either on CPU or GPU. But most of the time, we'll be using GPU because your tensors don't work on CPU. If we use something else to implement these algorithms, then we have some issues like tensor won't work on CPU. So if you don't have a graphic card installed on your laptop, on your system, then it won't work. And in that graphic card also, it requires NVIDIA graphic card. So if it doesn't have, then the system won't work, your codes won't work, and so you will have to run it on Collab only. Collab has the graphic card, so it has option to work on CPU or GPU. So there you can always switch over and use. So that should not be an issue as such. But if you want to use it on your system, like you want to use Jupyter or some other IDE, then you should have NVIDIA card installed on your system, a laptop or a desktop, whichever you are using. Otherwise, it won't work. Okay, you can work on the Collab, no issues, but it is a problem, and it can create a problem of out of memory sometime when the data goes high. It has limitation because your Collab is not paid Collab. Okay, we are just using the free version of it, so you may have a problem. So anyway, let's go through what we did today. The layers and all are there, so you can see that layers, and I'll have to explain them also. Although it is not there in your course, they have just mentioned ANN, and they did I don't know why they did not mention that everything has to be understood first, because by simply saying artificial neural network, it makes no sense, because your layers will have different things, different layers, we have different options, we have, so we have to understand that. Okay, but anyway, the syllabus is always written in brief, so we have to take a call and tell the students that this also is there, and this is how it works. Otherwise, it will make no sense, and you won't be able to implement anything. Anyway, so we have to do this neural networks, which is there in your course also, and then we have to that is the artificial neural network is there in the course also, and it is in good also, because we are moving towards transformers now, so deep learning is important. And now we have uh, boosting algorithms also, which is I think it's there, I think I've seen it in your course also. So we will be using few boosting algorithms. That is very simple, be taking in the lab. I'll be taking that in the lab. So we have cat boost and light GPM, which we'll be using. And here we'll be using covering the neural network again tomorrow, not tomorrow, on Friday. We have to take that on Friday, neural networks, and see what else we can do with that. And the most common of them is Lstm, which we use. So I'll explain the things first, and then we can see the implementation, how they are implemented. Right. So just stop the recording. I just recorded